class, what's up? Welcome back. We have our next video on 6.4, and today we're really going to dive into how to use the properties that we learned about in our last video, okay? So in our last video we learned a couple of things about rectangles. The first one is that a rectangle is a parallelogram with 4 right angles, so that's important. And the other big one is down here with the Roman numeral 2. A rectangle has diagonals that are congruent, okay? So again, 4 right angles, diagonals are congruent. If you ever see that you have a rectangle, these are the two properties that you can say. Alright, now moving on from rectangles, we learned about rhombuses, or rhombi, and there are 3 things to know about rhombuses, or rhombi. The first thing to know about rhombuses is that they have 4 congruent sides. Alright, so if all the sides are the same, you got a rhombus. Or backwards, right? If you know something is a rhombus, or let me rephrase that. If you have something with 4 congruent sides, then you know it's a rhombus. I think I just repeated myself. Hopefully you get the idea. Alright, so 4 congruent sides is number 1. Number 2, and this is the one that people tend to forget, so please try not to. Diagonals are perpendicular. Alright, the diagonals are perpendicular. So we know that if you have a rhombus, the diagonals have to form right angles there in the center, or in the middle. And the last one, when you have your diagonals drawn in for a rhombus, the diagonals actually bisect the opposite angles, right? So we knew, like when we were talking about parallelograms, we would call this angle and this angle the opposite angles. Well, we can go further and say that in rhombuses, those opposite angles are bisected. Now for squares, hopefully you remember, nice and easy. Squares just have to be both a rectangle and a rhombus. Alright, a square just needs to be both a rectangle and a rhombus. So whatever property that tells you it's a rectangle, and then whatever property that tells you it's a rhombus, if both of them are happening or occurring, you got yourself a square. So let's jump into some practice problems and applying these properties. Alright? So, UV WX, we have a rectangle. It says right there. We know that UV is 12 inches, so I'm going to put a 12 by UV. I'm also going to say, well, I know XV is 13, so I'm going to draw that kind of like doing one of these guys. Alright, this is length 13. Now I don't want to confuse you, right? This 12, you have to remember, is for the side. The 13 is for the diagonal. Well, let's see what we can do. XW. Well, XW we can do pretty nice and easy, right? XW is just the side that is opposite of UV. So, if we have UV, well then we have XW, and we can just immediately say that XW is 12. And why? Because if, and then be careful here, I'm still going to say if rectangle, then op sides congruent. Now I know this is a property of parallelograms, but I need you to remember that a rectangle already has to be a parallelogram. Okay? So any property that was good for parallelograms is also good for rectangles. Now, when I talk about UW, UW is the other diagonal. UW is the other diagonal. So I'm going to kind of try and sketch that in here with my purple. What do I need to remember about diagonals and rectangles? Well, if we go back, we learned what? We learned that diagonals are congruent in rectangles. So I know that if I have 13, I also have another 13 over here. And why is that? Because if rectangle, then diagonals are congruent. Careful, this is different. We're not bisecting the diagonals right now, yet at least. We are saying that the diagonals are congruent. Now, XM, let's look at XM. XM is from here to here. And what we need to remember here is what? Even though we're saying that we have a rectangle is still a parallelogram. Still a p-gram. And so if it's still a p-gram, Don't we know that the diagonals bisect each other? Absolutely. And so we can say that if we know the diagonal is xv, or let's say it like this, xv equals xm plus mv, all right? And we know that xv is 13, right? That was given to us. xv is 13. So 13 equals x plus another x, or 13 equals 2x. So when we divide 13 by 2, we end up with 6.5. And you know what? I just realized these are all inches. I should be putting units. Okay? So be very careful here. We have a rectangle, right? So if rectangle, but we're using properties of parallelograms. Then diagonals bisect each other. That is a property of parallelograms that still holds true for every rectangle and every rhombus and every square. All right, last one. UXW. We want the angle. Let's maybe change colors to make it a little. So we want UXW. We have to remember that in a rectangle, what do we have? We have 4 right angles. So I know that UXW is 90 degrees. And why is it? Because if rectangle, then 4 right angles. Okay? So again, we're using all of the properties that we've learned about, we're seeing how they fit, and we're setting up an equation to solve. Okay? Let's take a look at when we switch to a rhombus. So down here, number 2. Oh, we can do this. Okay, our STV is a rhombus. That's good. We want to find VT, and we want to justify. Well, I have nothing about VT, but I do know something about the sides of a rhombus. What's true about the sides of a rhombus? Hopefully you just said all sides are congruent. Boom, 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 boom. And with that in mind, we can set up the equation. 4x plus 7 equals 9x minus 11. How do we want to solve this? Oh, this isn't going to be very nice, is it? I'll move this over so I have 4x plus 18 equals 9x. Or 18 equals 5x. Yeesh. X equals, what is that, 3.6? Let me double check that real quick. Oh my gosh, 18 divided by 5. Yeah, 3.6. Okay? So we're going to go with it. 3.6. Oh, shoot, what did I do wrong? X equals 3.6. I want VT. All right, VT is a side. So just remember, all the sides are congruent. So does it matter where you plug in? It shouldn't. As long as you plug into one, you should get the other. I like multiplying by 4 more, so I'm going to do 4 times 3.6 and then add 7. 4 times 3.6, 3.6 plus 7. I'm getting 21.4. Let's just double check. 9 times 3.6 minus 11 is also 21.4. Okay, there we go. 21.4. Now please remember what we used. The reason we were able to do any of this is because we know that in a rhombus, if we have a rhombus, then 4 congruent sides. And it's as easy as that. All right? Okay. Number 3, I would say, is a little trickier. And number 3, well, it doesn't need to be tricky, is what I'm trying to say. It doesn't need to be tricky. You need to use a little bit of common sense, a little bit of thought. Don't be a robot. And understand, guys, we don't know anything about how this angle compares to this angle. Okay, so we can't just set these two expressions equal to each other, because we don't know if this angle is equal to that angle. That would be making stuff up. What we do know is that we have a rhombus. And if we have a rhombus, what is true about when the diagonals are drawn? Well, there's a couple of things. The one that we can't use just yet, but we do know that the opposite angles are bisected. So like this and this are going to be congruent to that and that. So we know that those angles are all going to be the same measure. But more importantly to this problem is that we know when the diagonals are formed for a rhombus, they're perpendicular. Okay, we have perpendicular diagonals, which means we have right angles in the center. And that's what I need, guys. I need that information because now I can set up the equation 2y plus 10 equals 90, or 2y equals 80, or y equals 40. Please note, there was not enough information to do anything with these angles over here yet, right? We needed to use the fact that diagonals are perpendicular to get that this angle has to be 90 and to solve for y. Now, what we can absolutely do right now is we can get that the measure of angle TSW, that's an S, is equal to 40 plus 2, or 42 degrees. What we have to kind of keep in mind is the relationship that because this is a rhombus, the diagonals bisect the opposite angles, so whatever I have over here is equal to this one over here. So WSR is also 42 degrees. Now really, guys, we did two justifications here. The first one was if rhombus, then diags perpendicular. The second justification was if rhombus, then op angles bisected. Alright, and we needed to use both of those properties or justifications here. Alright, the first justification, I'll underline in red, got us this part. The second justification, green, got us that measure of angle WSR is also equal to 42 degrees. Alright, so there's that. Alright, let's move to the next page. A couple more problems. These are all really good practice problems, okay? So stick with me. I think they're worth it. Alright, up here at the top, we have another rhombus, which is good. We then know that all sides are congruent, which looks like we're going to need. Sorry, bad tick marks. And I think that's all I'm going to mark for right now. Okay, so first things first, we want to get CD. Well, CD is a side. We know that all sides are congruent, so hopefully you agree that we can set up the equation 5a equals 3a plus 17, 2a equals 17, a is equal to 8.5. And now that we know that a is 8.5, we can plug it in. 5 times 8.5, 42.5. Just to double check, 3 times 5.5 plus 17. This calculator's awful. What did I do wrong? Oh, I did 5.5. 3 times 8.5 plus 17. Excuse me, sorry guys. Okay, 42.5. So we're good here. What did we know? We said because if rhombus, then 4 congruent sides. Alright, now that's the easy part. The next part's a little tougher. The next part is definitely a little tougher. We need to understand what's going on here. Okay, so we're given, and I know it's not on the picture, but we were given that GCD is b plus 3. Alright, so GCD, which is right here, and I'm going to write is b plus 3. I also know CDF, this one right here, I'm going to use doubles just so you understand what I'm talking about here, is 6b minus 40. Well, guys, there's a lot of different things we could do here. We could divide everything by 2 and set it equal to this little triangle. But at the end of the day, I also want you to remember, that first, a rhombus is a parallelogram. Okay, first, a rhombus is a parallelogram. And if a rhombus is a parallelogram, then what is true about consecutive angles? This angle over at C and this angle over at D. Well, they're supplementary. So I can set up b plus 3 plus 6b minus 40 equals 180. All right, again, this angle and this angle are consecutive, and we know that if you have a parallelogram or a rhombus, then those angles are going to be supplementary. So as we clean this up, we have 7b minus 37 equals 180. 7b is equal to 2, what is that? 217. And then that should be b is equal to 31. Good. So the last thing, it's asking for GCH. Well, GCH is right here. We don't know, we don't have a measurement about GCH, but we do have a measurement about GCD. GCD is 31 plus 3. Oh my gosh, I'm out of my mind. GCD is equal to 34 degrees. And what do we have to remember about GCH in comparison to GCD? Well, it's bisected, right? Or it's cut in half. So I know that this will be 17 degrees. And I can use a couple of things. I can say if parallelogram, then consecutive angles sup. And I use that. Why? Because I need to be able to get this part. And then my other justification is if rhombus, then op angles are bisected. And that I'll put in purple. Measure of GCH equals 17. And I know that from my purple explanation. Okay? Okay. What we're gonna do number 5. We're gonna skip the explanations right now because we're running a little bit longer than I would like to. But let's take a look at this. We have a rectangle, which is important. That tells us a few things. It tells us that all sides are going to be congruent because it's a parallelogram. It tells us that all the angles in the corners are right angles, which is important. What else do we know? Well, hopefully we can agree that because this is a rectangle, it's also a parallelogram. So I can say that these sides are parallel as well. And if that's the case, then what's true about this angle right here and this angle right there? Hopefully you said they are alternate interiors. So angle 1 is just 54 degrees. All right. Now let's think about this. Angle 2, there's a couple of different ways to think about this. To be quite honest, I would hope we could connect the dots and say, well, if I have a rectangle, then what's true about the diagonals? What's true about the diagonals of a rectangle? Well, they're congruent. So I can say that this diagonal is congruent to this diagonal. And then what happens if I take the same exact measure and cut it in half, bisect it? Well, that's also going to be congruent. So really, guys, what I want you to understand is we have isosceles triangles up at the top, the bottom, the left, and the right. All of these pieces are completely congruent to one another. All right? Boom, 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 boom. And so what I know is if I know angle 1 is 54, well, so is angle 2. Because isosceles triangles, right? If sides, then angles. Now, angle 3, we have to do a little bit of work, but hopefully we understand that because my corner is a right angle and I know this piece, well, 3 just has to be 90 minus angle 1. So that'll give us a 36. All right. For 4 and for 5, there's a couple of ways. For 4, I would strongly encourage you to understand that if you have angle 1 and angle 2, you can easily get angle 4. And why is that? Well, because measure of angle 1 plus measure of angle 2 plus measure of angle 4 must equal 180. So 54 plus 54 plus measure of angle 4 is equal to 180. If we keep going on that, what do we get? 108 plus measure of angle 4 is equal to 180. Or we get 72 degrees for the measure of angle 4. You could do the exact same thing with angle 5. You could say, well, this is 36 and this is 36, and so you know that these two, if you take them away from 180, you'll get angle 5. But I would just say, what's true about angle 4 and angle 5 from our picture? Angle 4 and angle 5 have to be supplementary angles. So if you know angle 4, you know angle 5 is 180 minus. And 180 minus 72 is 108. All right, so we just went through a bunch of examples of how to utilize our properties. Please do not worry about memorizing all of the properties. We are going to work on an organizer that should help keep your thoughts a little more together. Okay? All right, so we will practice more of these tomorrow. Have a good one.